Good evening, good afternoon, everyone, wherever you are. This is Mohammed Yaqub. I am faculty at Mohammed bin Zayed University of AI. I'm also the General Chair of MICCAI 2026. And today in the MICCAI Industrial Talk, we're glad to have an interesting talk delivered by three people. So over to the talk, and then we have today Dr. Chris Ross. He's a tech business leader for healthcare at AWS. And also we have Dr. René Hosch. He's the lead AI and data science and University Medicine Essen, and Mr. Justin Woolley, full stack developer at the same university. The talk is about accelerating development and deployment of the full body organ analysis app with agentic AI on AWS. So the plan is today that the gentleman will have about 40 to 45 minutes of presentation, and then at the end we'll have Q&A session. For the participant and the attendees, feel free to share your question in the Q&A box, not in the chat, and we will take care of that at the last 15 minutes. Without further ado, great to have you, gentlemen. Over to you, Chris.
Thank you, Mohammed. Really pleasure to be here and great honor to have such opportunity. So I'm really, really happy that we got to do this today and show you some examples of what we're doing in healthcare at AWS and with our great customers here from the University Hospital in Essen. So yeah, my name is Chris Ross. I'm part of the industry team for healthcare at AWS, and I've been working at AWS for over 4.5 years. And I want to show you a bit of what we did with René and Justin today. And this is our agenda. So I'll give you a quick introduction to what AWS is, for those who don't know, what AI agents are and how they can impact healthcare today. Justin and René will show us how they actually did that in practice after my short intro. And then maybe we also get to see a live demo if everything comes together, and then what's next. So who are we? What is AWS? Well, AWS is the cloud technology company behind Amazon. So Amazon Web Services was founded in 2006 and came out of the need of building scalable infrastructure to deploy workloads globally, right? So you have a huge portfolio of innovation at Amazon. I can't cover all of this today, but maybe Alexa, delivery centers that distribute our products across the world. And healthcare at Amazon is also a specific topic where in the US you have One Medical and Amazon Pharmacy that help deliver products and make healthcare more accessible to people around the world. Now, AWS for healthcare, this is where I work, has a specific industry specialization with dedicated people that help customers in this space and how to adopt AWS services. And our mission is to really make this more accessible, more personalized, and ultimately create better outcomes for patients, of course. But today we want to talk about agentic AI a bit. So what are AI agents and how do you see that? It's a big topic today, of course. I think everybody has heard the terms. Now, the definition we can define as autonomous or semi-autonomous systems that reason, that plan, and that, of course, want to take some action and pursue a specific goal, either in the digital world or also in the physical world today. Now, a few statistics from the enterprise view. I think there's a big focus on integrating agentic AI into solutions today, with the expectation that by 2028 we have almost 33% of the enterprise software utilize agentic AI. So I think this is a topic everybody has heard about by now. How does AWS think about this? Well, we have in principle at AWS the focus to offer choice, right? We want to give you the choice and freedom to innovate with a broad selection of tools. This includes different models, so giving you a broad selection of models that you can choose from, frameworks that are open source running on AWS that help you build agentic AI solutions. At the same time, we want to enable trust. So you need to have trust through governance of AI. So building this on AWS will help you do that. You also, of course, we're AWS, so we focus on scale. And reaching your collaborators is often in the medical field, in the research field, an important topic. So I'll show you a quick example of how we did that with a university medical center in the Netherlands that you might know about, which is very well known in the MICCAI community, I believe. But before we get there, so whoever you are that is listening today, AWS can go and help you in different ways. So you can look at turnkey solutions. We can just use Amazon Quick Suite as a turnkey agentic AI solution to help you accomplish your goals faster. You can build your own agents, of course, with Strands framework or others on top of Amazon Bedrock Agent Core. We also have a portfolio, of course, of partners, as well as our Generative AI Innovation Center that can help, and people like me that work with you directly. So yeah, feel free to reach out and see how we can help. But we want to talk a bit more in detail today about how to build with agentic AI. And for that, before I hand over to show you more what Essen did, I want to show you one thing, which is Kiro. So Kiro is actually an IDE that helps you build faster and that can make you go from prototype to production in days, basically, or even faster if we're listening to what René and Justin will tell us. Now, what is the specifics of Kiro? Well, Kiro is driving what's called spec-driven development. So in traditional vibe coding setups that you might be aware of, you just ask for code to be generated, for things to be built. Kiro is helping you to really change the process a bit and go from this prompt-based engineering to also a spec-driven thing. So you actually create the requirements first, you define what you actually want to build, and then you iterate on that so that you get a cycle of kind of how to build things fast integrated in your tool. And you can get that today, and you can use it like a normal IDE that you know, powered by different models in the background. So go and check it out if you get a chance. But of course, you want to build something scalable, right? So you all can build apps quickly now, but how do you run them at scale? And how do you power these applications with the storage or with the AI services behind it? Well, for that, AWS offers healthcare-specific solutions. So some of these services I want to show you quickly. One is health imaging, which is focused on medical imaging storage, where you can really scale to petabyte as solutions that store, transform, and analyze DICOM data for you. And packaging all of this, and I promise I'm almost done with the service overview, is our package of security, governance and auditability. So building all this is great, right? But you also want to make sure, like I said, that you want to have trust in your solution, that you can audit the solution, especially in healthcare. So there's a number of services that are very valuable that help you do exactly that on AWS. Now, to my example that I wanted to give you before I hand over to my friends here is Radboud University Medical Center. You might be aware of, if you go to MICCAI conference occasionally, as some of you might, there are many workshops as part of the conference, right, where you might host a challenge on grandchallenge.org. Grand Challenge is powered by AWS. I work with the team at Radboud very closely, and they now have 130,000 users on that platform and really scaled to 1 million inference jobs by now, with over 100,000 predictions that they calculated. So it's really an amazing story. I have a blog post there linked for you. So if you want to read a bit more in depth on how they build something to scale to 100,000 users for medical imaging in the space largely of MICCAI, then go and check it out. And with that, I'm very happy to hand over to René and Justin and let you take the next step.
Okay. Thank you very much, Chris. First of all, for the nice introduction and also for the nice handover. So I will quickly check if the remote control works. I think it does. Okay, so hello again from our side. It's very nice, first of all, to be here, that we can show our work, our models, and also the collaboration with AWS. And before we start, we would like to introduce a little bit our institution and our hospital. So first of all, the University Medicine Essen is one of the largest hospitals in Western Germany, or academic centers. We have a capacity around 1,700 beds, which is quite much for especially European or German Germany. And we also have around 11,000 employees, 24 institutes, which is also a growing number, not fixed. And what is also quite special about our institution, and I hope it works now with the control. Seems like it does not work. Maybe now, okay. So what we also have, and which was what was founded in 2021, which is quite special, is an own institute for artificial intelligence, the IKIM. And when you think about it, we were founded in 21, and we have around 5 professors or research groups, which is also a quite growing number. We were able to expand the number of employees, research assistants, to around about 120, which is quite much for our institution, and also our size. So just to give you a bigger landscape of what we are doing, it really expands about starting in radiology, going over genomics, going into large language models. So really the institute is present in every medical discipline and also AI discipline, which is currently very, I would say, hot topic. And this is a little bit the foundation where we build it, or where we build on. And as Chris said, in last year, we had the idea that we would try to bring one of our models, which is an image segmentation model in the field of body composition, that we would bring this in collaboration, or we set out the goal in 72 hours that we want to bring this model into a web-ready application and an AWS cloud setting. So when we thinking about this, I have to say that it was really, for us, we had not so much knowledge about AWS, about the components. So really Chris and the team, the solution architects came in, they had the knowledge and we had our great ideas. And then we really sit together 3 days to build a new application. So what we have done there is, first of all, the question why in the first place moving to the cloud. I mean, if you're coming from healthcare and also all the people around MICCAI, there's a lot of traction in models, what is possible, especially in the last 2 to 3 years. There's really an explosion of what we can do with AI models in the medical field. And the workshop had the idea that we translate from, I would say, a research-ready application to really a more like a scalable research-ready or product-ready application, so that we can build an app that scales, that we have, auditable, as Chris already showed, auditable resources, which we could stick together like building blocks and therefore build a really production-ready pipeline for an AI use case. And that was the idea. As I said, we had like the 72 hours, we had the infrastructure and the app in the beginning, so that we outlined or that we also onboarded the AWS team, what are our models currently doing, and also what kind of potential user-facing sites do we have, what kind of features, what kind of benefits. So it was really a little bit like sketching around, like how should the app look like, what kind of features should be implemented. Then, of course, bringing all together, developing the app, but also bringing the AI models, the inference to AWS, which is or was also a big part. And then, of course, also a lot of testing, debugging, etc. And of course, I mean, I have seen it in different other workshops with AWS. Normally on this slide, there's also the number of coffees that we had in the days, and it was really enormous. So just as a side note. And this was a little bit our mission. And of course, when we are talking about agentic AI, I mean, if we are really honest, you cannot do this with 4 to 5 people in 72 hours without support of agentic AI and also the abilities that we have currently with the models, with large language models. So what was also a very nice note of the workshop or goal was to combine all these different kinds of agentic AI solutions, large language models together with the classical, I would say, image-based models in a segmentation approach to, first of all, scale the development process. For example, we have Amazon Q, which is really good in Amazon knowledge. We use different kinds of other language models, which we use for rapid prototyping, agentic workflows, and just that we really, it was for us a little bit to challenge what can we really do in 72 hours. And before we dive deeper into the AI models. So first of all, maybe some in this call are familiar to body composition, but if I talk about an AI model, an image-based model which can capture body composition, it's about that we really use all the features that we have in medical imaging, that we can define body composition as the whole picture in terms of muscle volume, bone volume, different kinds of adipose tissues, but also, of course, organs and organ volume, and that we really can capture this image. And with this, I mean, this is a slide where everybody is, I think, working on daily. When we talk about the plain body composition and the theoretical side of it, then we have, of course, first of all, genetics and inherited traits from the family, from the parents. So we all have, like, I would say, one fundament that we build up on. Then, of course, we have like the metabolic and hormonal health and different kinds of aspects there. But then there are 3 to 4 aspects in terms of nutrition, in terms of diet, but also in terms of physical activity and lifestyle, which we can really use those first 2 fundaments and shape the body composition in a specific direction. And if we then take a look, what is, I would say, not state of the art anymore, but what is really wide used in medicine. We have like different kinds of methods to measure body composition. So many of you know bioelectrical impedance. We have entropic or anthropometric measures. We have waist to hip measurements. I mean, if you go to a gym or if you have a gym membership, you always see a lot of people who are using this caliper where you measure like the fat distribution in your body. And what you also have, which is, I think, more known, is the body mass index, which is basically the weight to height ratio, which is quite wide used also in medicine for research. And we have brought 2 friends, John and David, into this call for us. So to just give you an idea what is the potential downside of those traditional measurements. And as you can see, they are both or have the same height. They also have nearly the same weight. But of course, what we can see from the body picture there, they are quite different. David is a little bit more muscular. John, not so muscular. He has other advantages. And when we then look at the body mass index is nearly the same for both. But I think we can all agree that we would not rate those 2 persons in the same category. But the BME, for example, does it. And that's why we, as in Essen, we say that it's not only relevant that we have like some rough measurements or approximations of the body composition, more that we really want to say that the whole picture, the whole body is important. And for this, to get a little bit more technical, of course, we developed, as I said, different kinds of AI models, segmentation models. This one here is called the body and organ analysis from our institution. So also a little bit of history there. We developed initially around 2018, 2019, a first in-house body composition module. And I think also in the MICCAI, it's well known that we have like models like the total segmentator, we have muscle map, we have a lot of AI models and segmentation models. And what we did with the BOA is that we combined our in-house body composition network together with the total segmentator and different other open source models to produce this nearly full segmentation of the body in an CT. to then, of course, enable quantifications of body composition, how many muscle, how many muscle volume, how many fat, different kinds of fats. We have, for example, subcutaneous adipose tissue. We have visceral adipose tissue, so the fat around the organs in the abdominal cavity. We have, like, for example, intramuscular adipose tissue, which is also a very important marker. And yeah, we combined all of this into one big segmentation model. And we also, of course, open sourced it. So if you're interested in the model and also to use it, you can do it. We also open sourced a data set, which is called Saros, which is like an open source body composition data set, which you can use to develop your own models or to combine it with different kinds of other open source data sets. And what we also did is going the next step and going from CT imaging to MR imaging. So what we can see here is like the Bohr MR. You can see that we also have like a body part segmentation on the complete left side. Then we have like also the tissues, the body composition, and we also have like a dedicated muscle segmentation, which we included via muscle map, but also like the visceral fat on the completely right side. So the goal was to completely transfer it from radiation-based imaging to also radiation-free imaging. And of course, this is also, the models are published. We have the studies for CT, also to bringing the CT variant to MR via generative adversarial networks and so on. So you can give it a look and yeah, try it or read it. And what we then did a little bit, also what we want to try in this workshop is, of course, we have those models, we have the technical grounding and fundament, but we wanted, as we said, we wanted to bring those models into a more user perspective. And there, of course, it's not very the CT variant very in the focus. It's more like the MR variant. And what we wanted to try is that we create an app for a user which is interested in their lifestyle, in their health, in their body composition, using whole body MR imaging with the provided models. And if you take a look at whole body MR imaging, I mean, it's really a growing market. We also have like a lot of public interest in it. For example, a few weeks ago, a very popular person from the US, which has an electric car company, also twittered, I can say Twitter, I think, but twittered that we should introduce whole body screening for our population, for early detection, for also maybe tools like this. And I think there you can see why this could be also for interest for this application and the usage. And of course, as I already said, why MR in the first place? First of all, it's radiation free, so the patient has no downsides in it. It has a very good soft tissue contrast. So in terms of adipose tissue and other stuff, it's very good, distinguishable. We have the full body protocols which are available, and of course we have a reproducibility. Of course, everybody who's coming from a radiomics background now will say, okay, reproducibility is in MR especially challenging, but in terms of body composition, if we talk about anatomical structure, I think we can all agree on this. And therefore, we had like the challenge with the team to have the users in mind, and we have two users here. We have the radiologist, and we also have the sport enthusiast, who are both in relation to the app that we built. So the radiologist, of course, he has to conduct the scan, send the data to the AWS app or to our app, which is running on AWS. And then also we have like the user who wants to consume the information that we have in a very practical manner. And for this, we in our workshop, we created this user story that we have like an initial beginning. So you can book an appointment for a whole body MR scan in your local radiological practice. You then go to the site, have the scan at the location. You then, if you're finished, go home. You get a results notification via email with your report, with your results, and then you can consume it basically. And this is the basic setup. If we want to make it a little bit more technical, we have it here like a little roadmap that we had in the workshop. So that we clearly outlined in the team what are the parts. Then we could discuss it with Chris and the team, which kinds of components are relevant. How should we use, for example, AI inference to compute at AWS? It's very important, especially if we're thinking about scaling. So this is like a little bit more a technical side. And now we go completely technical. We have this. It's like a little bit like the infrastructure that we have, that the team built in the 3 days. And we will not go into detail here because it's a little bit very detailed. But what is important is that we have 2 sides. We have like one software that is running at the radiological practice. They are sending the IKIM images to a specific gateway, which then sends the data anonymized to the AWS cloud, and where then everything is computed and sent back to the practice. And at the same time, if the compute in the cloud is successful, it goes back to the user. And now I think I hand over to you, Justin, right?
Yes, thanks, René. As René said, we had a focus on how we want to structure the application and how we wanted to strategically have the radiologist and the end user in mind. And this is a walkthrough of how the user story goes on both sides. So the journey starts at a radiological practice or clinic, completely standard. A completely normal full body MRI is acquired with the completely normal protocols that they use there every day. They don't need any additional hardware. The only new piece, what we introduce is our gateway. It's a small piece of software that runs inside the clinical network and can accept the imaging data being sent there as part of the usual workflow that the practice already employs day to day. So that doesn't create any more friction or any new work for the people there. Once the data arrives at our gateway, we then need to get the data into AWS. And here's where we had one of our first interesting design choices. The gateway doesn't push data directly through our backend to S3. Rather, our backend generates a pre-signed S3 upload URL. That's a short-lived scoped upload link that only is valid for one upload, and we can directly put the data into S3. This matters because our backend then stays stateless, and we also don't have to publish any credentials for AWS to the local sites. Once the upload has been completed, we verify the integrity of the upload data by creating a checksum and checking the file size, so we can be sure before we start any inference work that we have the right data from the patient or the user. Once the scan is in and the results are there, the patient needs a way to get their results. And we deliberately made this as low friction as possible. Every report has a 10-digit code, passcode, and a report ID that is included in the email. So the user just needs to click the link, enter their ID, and they can open it. So we have a 2-factor authentication by design. We don't need an account to view your results. You can create one. I'll get back to that later. But for the normal user, you don't have to create an account. This is our main core of the system. So this is where everything happens. So the moment the MRI lands in S3, an S3 event triggers our orchestration pipeline. So we don't have any idling resources, no polling, no waiting for anything. and upload itself is the trigger for the whole pipeline. Once the upload is confirmed and done, it triggers SageMaker, which runs our AI models and calculates the body analysis. Once the model finishes, the results flow back into S3, and the metadata, like the pipeline IDs and the link to the passcode, go to DynamoDB to be able to be looked up in an instant. This workflow is completely serverless, it's completely event-driven, and the most important thing, it's scaled. So you can have, one day you can have one scan, next day you can have 500 scans, and you don't have to change a thing about how you implement it and how the code runs. Now back to the account I've mentioned earlier. If a patient decides that they want to track the results over time, and most do once they see it for the first time, they can create an account in less than a minute. They just need an email and a password, and then they're in. The clever part is they can link all their existing reports to their account and get a lateral overview of how things have changed and what has already been done. And they can link all the upcoming scans also to get a best overview of how their body is developing. What we also created, and what is René also mentioned earlier, is that we can have we have an LM layer where the patient can chat with their result, and they can have a real conversation about the result and ask questions like what changed, or what does specific findings mean or specific values mean, and it can explain it in layman's terms, but being grounded in medical research and their result. So it's not just something the model makes up, it's grounded in their specific report. The way we made that work is a classic rack structure. So Lambda here works as the orchestrator for all this rack steps. In the first step, the knowledge base is queried via Amazon OpenSearch. The second step is to get the result and reports from Amazon S3, and then once those two steps have run, the queried results and the knowledge base is passed to Bedrock to run on an LLM to take those data in and have a based information exchange on the specific data. This is the most complex architecture of the whole project, but I'd rather stop talking about how it works in the background and let René show you how it works in the real world. One second.
Thank you, Justin. I mean, you can open the demo in your time. But I think what's very interesting, what Justin showed, is like that we really have gone full circle in the workshop, so that we were able to have an idea. I mean, of course, the AI models were there. We did not have to train, to fine-tune anything, but to have those models coming from research and then sitting there 3 days together and building something what you can see here now. And just before we dive into the app, also like what Justin mentioned, also to have the flexibility to say, okay, we want to have the feature that a person and sports enthusiast can chat over their body composition, but also we can combine it with different kinds of knowledge bases, either publications, but also like what we saw in the slide in the last slide from Justin, like that we have different kinds of training. So we could also combine it if we have dedicated muscle volumes, asymmetries between left and right side muscles that we then can create, for example, for a user as a user experience, then complete training programs based on those results and findings. And this was really amazing to see that it's possible with the components that AWS provides. And maybe now, Justin, we can log in to give a better overview besides the static screenshots that we have. And I mean, it's a little bit redundant, but I think it's very nice to see the application. So of course, this is now a user that is registered, what we now could do is that if we have gotten a new result from a new scan, maybe 6 months after the first, 1 year after the first scan, we could enter the report token and the 10-digit code and could connect it to the user and add the results. So, but we don't do it here. So we have a report from beginning of the year, and that's basically where the user gets their insights. It's also divided based on different categories. So on this slide, we have a broad overview. So we have the body composition of the whole MR, whole body scan. We have the distribution, for example, how much muscle volume, how much subcutaneous fat, how much visceral intramuscular fat, etc. How many of the voxels in the scan which do not belong to tissues or body composition are belonging to organs or remaining classes. And what we also have here, I mean, maybe some of you have seen it in the slides, that we have that we can calculate the asymmetry because we can capture the sides of the body. Of course, we can also calculate which side is more dominant in terms of muscle, in terms of fat. And what you can see there, for example, in the bottom right corner, we have like the balance, and you can see that the arms are completely out or asymmetry. It's not like that the person has some kind of disease. It's more like that MR scans, because they have a reduced field of view, that they normally cut off a little bit the arms. And this one was a scan where we saw that we have like completely cut off the right arm, and that was also going into this classes. So just as a small side note. And then we can go through it further. So we have then also the body composition or different body regions from the model. So for example, we are able to gather either the information in terms of the tissues for the whole body, but also for the abdominal cavity region or for the thoracic region. So depending on which kind of region I'm interested in, also for the different kinds of extremities or the whole torso, we could do it. And visualize it also in different ways so that the user can consume it or really can make a deep dive into their body composition. And then what I think is really interesting, which was also a feature, is like, okay, we have our body composition and we are talking about sport enthusiasts. So one of the main features is that we also looked into research and search for norm values or also comparisons to, for example, athletes in different kinds of sports. So, for example, we have numbers for tennis, for soccer, for running, for sprinting, for cycling, etc. And then you can compare your own values or the values of specific muscle groups, because you can imagine there's not like the publication which really uses the Premier League and the Bundesliga and says, okay, these are the perfect norm values for profi soccer players. So we took what's there and combined it in terms of the different dedicated muscle groups which are relevant for the sport. And then you can see if you are more like a pro or if you have a long path ahead, if you want to be better than a pro and so on. And that is also enabled in the app. And maybe also goes hand in hand with the last tab that we have, like the muscle insights, because it's also, as we said, enabled that we have like a really detailed muscle segmentation in the AI model. So it's an own model where we can segment the different kinds of muscles in the different regions and then can compare it side by side. For example, you can see on the right side the differences, which side has more volume, etc. And also calculate and compare it with the norm values. And maybe to close the demo, also what Justin said, we have like a little bit of grounding. I mean, we are coming from a research institute. We are not like that we imagined those numbers. So we have a database, and we also collected a database, a colleague from us in the workshop, in terms of body composition values. We have expanded it in the meantime in terms of the athlete values, and it's still in a very advancing field. If you take a look into body composition research, also in the really medical domains like oncology, etc., but also like for in the athlete space, I would say there's a lot of going on with this way of really capturing the whole body. And yeah, that's our short live demo. Yeah. And I think with this, we are finished with our talk. And thank you very much for your attention. And I think we are open for questions.
Thank you very much, René. Sorry, go on.
I'm not quite sure because Chris, you had the promotion, so I don't know if it's now the right time or later.
Let's go back to Chris, and then I'll take over from that.
We can show it at the end, but there's one more invite to everyone here for in a couple of days. So I can share it now quickly, and then
share it now, please.
Okay. So yeah, also thank you, of course, from me, and we want to link up with you for once, of course, but also give you the opportunity, if you happen to be in Hamburg or close by, that is in Germany, of course, then stop by on Wednesday this week, where we'll talk a bit more in depth and in person on the topic. And so feel free to check it out. I'm looking forward to that, but that was the only addition. Thank you.
Thank you very much, Chris and everyone. I'm sure there must be someone in the audiences from Germany. Honestly, if I'm honest, the society has a large number of people. A good number of them are from Germany. There's a very strong research institute in many different universities in Germany. Okay, enough of that, please. Everyone else, thank you very much. If you have any question, everyone else, please share it in the Q&A box. It was a very interesting talk, and I'm really interested to ask a couple of questions before I move to the audience, if that's okay. So can you, so René and Justin, did you actually start from just a segmentation model? Is that the starting point? What was it before you built the 72 hours? Was it just a segmentation model, or did you have even more things?
It was really just a segmentation model. I mean, of course, in terms of for our clinical research, we provide like PDF reports for the clinicians where they can consume the body composition information. But in terms of what you have seen here with the voximetrics and the web application, it was really like a blank page at the beginning.
So the whole application, the analysis, everything, it has been done in 3 days worth of work, sort of.
Yes, yeah. Okay. I mean, of course, to be honest, we also improved it. It was like for us also very interesting, as I said, to see like, wow, this is really possible, and it's, I would say, very convenient if you're once in the AWS cloud, and with the building blocks, you can really, don't worry. You don't have to worry about the infrastructure and so on. You can just building your product, and that was for us also like a kickoff, like to how can we drive it further.
Fantastic. So am I right to think you mentioned it's based on total segmentator for MRI scans, right? As a segmentation model.
Yeah, it's one of the models that's included. It's for the organ segmentation, for the body composition segmentation, we use our own in-house developed models.
So the question I have or follow-up on this is amazing. I mean, we used to spend ages to build an app like this. And I've been through it myself. But the question is, isn't that also scary? Because now, if someone can just take and build with whatever tool, whether AWS or other tools, we know there are many other ones that are great. So we'll see many competitors, to not just you, to many other companies. What are your thoughts on, like, what is the difference? Where is the difference now? Because in the old days, like, the difference is in the research, in the development, in the nitty-gritty of development. And now I could take, say, total segmentator or an in-unit framework or and put it into some sort of mobile development apps and so on, and it gets me like a product. So what will distinguish people and different products at this stage?
That's a very, very good question. I think we could talk the next 45 minutes about it. But from my point of view, I mean, it's more like now we have like the moment where we can take the creativity that a lot of researchers, a lot of people have. And in the early days, it was more like, oh, I have to build a web application. I have the model, I have my research, but now I have to build something HTML, CSS, etc. And I don't want this, and so on. And now we have, like, based on those tools, we have the possibility to really rapid prototype applications, put stuff together. And I think so. This, first of all, a possibility to lift the creativity that all the people have and the researchers have. And then what distinguishes you from the rest, I think, is that you have really a good, first of all, a good product, because we can build something, it's not a good product, right? I mean, you have to have a good idea of your customers, of your solution, what are the ins and outs, and also you have to have a good connection into the market. So I think these are, like, what distinguishes you.
And on top of that, I think the research at Essen, I mean, you guys are very well known in the field when it comes to do the research perspective. So you have this as a background knowledge that support everything. Okay, there's a question on the Q&A box, and
before you go there, Mohammed,
yes,
I think it's very, very good point to think about, like, the lowering this bar of entry, right, for people. Something that traditionally, right, took a lot of effort, how to build things production worthy, let's say, or ready for kind of real use in a way, which was, I think, always a blocker in research. And we've been talking about how to bring things into the hands of clinicians, into the hands of users faster for, I think, decades, honestly. And I think now we're at a point where you can say, well, you can do it, or even the people that want to be the users, they can do it for themselves, right? So I would even take a step further. It's not just competitors or like other people. It's like everyone in the healthcare space that now wants to build things, they can use these tools to do that and to try things out much more easily than it was in the past. It's no longer just a research algorithm that lives somewhere and then is hard to utilize, but you can actually, in this space, as a healthcare professional, try things out, right? And that's where, you know, you really start to see the benefit, and like the way we're going to access tools, I think, is going to change that way. And it's going to benefit people from being able to use things that they previously simply couldn't, right?
Absolutely. No, absolutely. I'll come back with another question. Let's take some questions on the chat. So Mona is asking, thank you, everyone. I had a question regarding the future integration of continual learning into agentic medical AI systems. How do you envision continual learning being safely integrated into agentic clinical systems operating in long-term evolving environment? Interesting question.
Yes, very interesting. Chris, do you want to go first? Should I go first?
Go ahead.
All right. Yeah, I mean, it's of course, it's a very important topic because, I mean, already at the moment, we are evolving at a scale in terms of models, in terms of knowledge that we never have seen before. So I think also in terms of the continuous learning, especially if we include something in clinical workflows, then we have to adapt at some rate. I don't have a good idea how we do it, but it has to be thought of for the specific use case, whatever we have. I mean, if we, for example, have a medical imaging model and we introduce new classes because we see from research that, for example, there was a research study, I think a few weeks ago from Harvard in terms of TIMUS health. So for example, and there is like, they segmented the TIMUS region, and it's a very important biomarker for a lot of clinical outcomes. Then we also have there like the continuous learning. We have to adapt the models. In terms of language models, that's also, I think, at some point technically a little bit easier, but also more challenging in terms of the outcomes. I think it's also, it has to be implemented, but there's not like one fits them all solution for continuous learning, in my point of view.
And I would add that it's not just continuous learning, right? It's even just the speed of innovation right now that we're seeing. Every 3 months, every 6 months, you have major model releases, excuse me, where you need to ask, like, how do you get them reviewed, evaluated, right? So this is also something that needs to, or can be improved, or we'll see a lot of innovation, I think, in the space of how we certify products like this. How do we continuously evaluate models that live in production somehow, or that have to be updated fast, right? because the life cycle of these models is not as long anymore as the healthcare industry kind of looks at things. So I think that will be a big focus on like certification mechanisms, automation around that model monitoring, and these things are going to be super important, I think, going forward, to which will also impact kind of continuous learning improvements as part of this, I think.
Thank you. Next question is, I think the app is fantastic. I admire the research. Of course, it requires CT and or MRI, I guess. The question is, are there any plans to obtain this information using full body photograph? Because I guess MRI is expensive. I mean, you don't have it everywhere. Not everyone has the luxury to have MRI. I guess this is probably more of a research question. Like, would the research reach to the point where someone could take a photograph and perform a full body composition assessment?
We already had the idea in the team and have discussed it also. I can say this, but in terms of the presentation, also our research, I mean, we are going from rough measurements like the BMI or other values. And I think it's the same, but with an image, because we cannot obtain really like visceral fat or different kind of other adipose tissues from a photograph. But what then is really interesting, do we really have to conduct typical MRI sequences like T2 haste imaging, for example? There are also a lot of vendors which have like specific localizer sequences, which can be conducted really fast. We're talking about seconds or half a minute. And then you can try to optimize those sequences and to run body composition on those sequences. And that's, for us at least, from our research group, a field where we invest a lot of time at the moment to see how much acquisition time on MR do we really need to have a validated and good body composition with the models that we have at the moment.
Okay, so next question, just jump directly to the question. Can you summarize which AI agent were used to accelerate the development and deployment, and how you exactly use them? I assume you used coding agents, but did you, for example, use the spec-driven development that Chris showed the start to develop the shown voxel, the one you showed, voxel matrix application? So it's about the exact agent that you use to accelerate your work.
Yeah, the exact agent. So honestly, we used a number of agents because, as I said, with the team and Chris, we had also like the Amazon Q. There's also like a model for the Amazon components. We did use a lot of Cursor for the web application development, also ChatGPT, very classic and basic. But it's also like in the workshop, especially, was a little bit like preferences of the team and the member, and also like on which field they are working on, because there are also like different kinds of advantages for some models at the time, which also changed. But we were there very flexible and used a number of agents for the development. And I think also for a lot of parts, so for front end, of course, because front end is mainly boilerplate writing. It's very repetitive. And it went also down to CDK development, which was then checked by the team from AWS. So it was really the full bandwidth, besides model development and training, of course.
Maybe to add, I love this, and you see the diversity of setups. Of course, everybody has their own preference, and as I said in the beginning, right? So choice is super important for us, and we know that people want to use their tools that they like and they prefer. So you can run pretty much everything that René just said on AWS in a secured environment that is set up for you in your account on AWS. So if you use Cursor, you can run it on Bedrock. If you use Codex from OpenAI, that'll be available on AWS. If you use Kiro, which we tried out during, I think, the workshop as well, that has actually a multitude of models, including from Anthropic and others, Nova models from Amazon, plus open source models that really allow you kind of to flexibly choose which ones you want to use. There's really the idea that it's not just one solution, right? It's whatever fits you, and how do you then build with that in an environment? And clearly, you will use MCP setups. We have a bunch of relevant MCP servers that we host to make this easier to integrate with any setup you have as well, to get access to documentation, to the AWS interface, even to deploy things. And these things are really something that you can start today, and it's very. We can share this afterwards, I guess, on how to use them for yourself. But yeah, that I love this diversity setup, and that's what we're here for, to support.
Excellent. Last two questions. We'll do so. Seven, hi Seven. The question is, in the LLM discussion section, personalized recommendation. Could you please be okay? Personalized recommendation could be please provided from the user patient perspective. For example, if elevated body fat level are detected, the system may suggest appropriate exercise, for example, from YouTube. Do you have such tools for specific to patient, like to know where to focus on if you know that the triceps may have problems, and I don't know. Is that probably the question? Like, does the system at the level where it can provide personalized suggestions?
Yes, in terms of now how do I phrase it correctly? In terms of lifestyle and training directions, of course. So if we have a report and we have like a big asymmetry between, for example, the triceps on the one side to the other side, the model could potentially propose a training plan which focuses this if the user wants it with specific exercises. But what the model does not do, and where we also have to differentiate, is it does not give any medical guidance or diagnosis or anything else. It's really like built for lifestyle and training exercises. So not that we confuse this with like medical guidance. Elevated fat could be related to this and that diagnosis. That's not what the system does. It's more like the lifestyle and optimization area.
Okay, sounds good. I think that's all the questions. I think last question just jumped out from the Q&A box, which is
I just posted some links so we can address it if you want. I didn't know the question would go away from that, but I think it's in the answer.
I mean, it's all about data privacy, I think. So maybe do you want to guys comment on data privacy? Because yes, I mean, putting things on the cloud, that's something.
So I can start.
In Europe, it's a tricky thing, at least.
Yeah, so it's a very important topic. Fully agree with the question on like how do you improve your data privacy setup? How do you stay compliant, right? And it's very important for this sector. I posted some links there for everyone to see how people are doing it in Germany with full migration of hospitals to AWS, with all data, all applications in the cloud, and you can do that through like supported encryption setups, compliance setups that are audited. So I think the question is like, why wouldn't you do that? Because if you have a need to have consistent compliance, and now you have the added need of like integrating applications into this to benefit your workflows in the healthcare industry, how do you do that? Because ultimately you're turning to lots of solution providers that will help you do that. And now you need to run them, and you need to orchestrate them, and you need to provide compliance around this. The best way to do that is on a single ecosystem where you can put these things together, have centralized security controls that are industry grade and really world leading. So I would suggest to check it out, because it's really not an issue to stop people from putting patient data. It's a question of how you do it and how do you stay compliant, right? And there are great guidance articles that we published on how to do that, how to ensure all your data is encrypted and only accessible to you. There's no operator access and things like that. There's even a whole European sovereign cloud that we launched, fully operated and managed out of Germany, partly because we know that there are specific compliance needs in Europe where you want to, have a very sovereign setup, and that is enabled through, European sovereign cloud. So there are answers to this, and I think that's unfortunately a misconception. I actually think you can increase the security posture and you can improve your setup if you go through industry standardized solutions like on AWS.
Well, thank you,
for René
gentlemen.
and the team to also jump in.
Yeah,
unless there's
maybe.
anything to add, please.
Okay, I make it short. But from a customer perspective or a hospital's perspective, I would also completely agree with Chris in terms of the opportunities, because I mean, you have to be compliant. You have to have the guarantee that the data is handled correctly. And I mean, what of course researchers but also companies are doing, they want to develop a product that helps somewhere in medicine or provides a service that helps makes workflows more efficient. And I think if you then have like this compliant fundament of infrastructure where you don't have to worry about, you can just rely on that somebody worried about it, and it's a very good fundament. And then you can focus as a company or as a team on developing the application, the algorithms, the workflows. I think that is also especially important in this very fast-changing, innovative medical world that we are living in. It's also like a necessity to be innovative today, because we have to put something out. The possibilities are there, but we have to do it compliant. And I think that's also in terms of what Chris mentioned, but also what are also there for options. It's like a necessity that you have like something or infrastructure that is compliant, especially for healthcare.
Okay, so with that, I think that the talk is coming to an end. And thank you very much, Chris, René, and Justin for the interesting talk. I think it's an exciting tool that you've built. We look forward to seeing it becoming better and better, and hear about it more into the MICCAI community as well with more publication. I think there's a lot of room for research on this domain as well. Okay, with that, thank you very much. And thank you very much, everyone who joined us today. Please join us in a couple of months for another interesting MICCAI Industry Talk. Thank you, gentlemen.
Thank you.
Bye-bye.
Thanks very much.
Bye.